Hello everybody and welcome back to Calculosity. It's your host Corey and we have another fun lesson planned, which is calculating limits with tables. So previously we discussed how to calculate limits algebraically, but we determined that algebraic limits, they don't have a lot of room for finding sidedness. That is, finding the left hand or right hand limit when they're not equal to each other. In these cases, we actually have to concern ourselves more with what the tables of the functions look like, and we have to come up with some sort of estimate of what the left and right-handed limits are going to be, rather than having an exact empirical value. So that being said, let's figure out how tables can be beneficial to us. So, typically in a problem, they would lay out a table of values for us. And in that table, they would give us the x's, and they would give us the y's. And then they would hand you those values and say, hey, work with these and figure out what the limit at various points is going to be. So oftentimes they'll give you some sort of center value that you're trying to find, like x equals 3, for example. That will be a y value that doesn't exist, something that doesn't exist. But they will give you values around it, and that is what will help us find the limit. So they might give us something like 2.9. 2.99, 2.999. Forgive me for having terrible handwriting. 3.0001, 3.001, and 3.01. They might give us x values like this, which are just x values that are very close to 3. So the whole objective here is that we're trying to move in on 3 from either side, with very, very close x values that are, fractional amounts away from 3, without getting there. A function that would cause a misbehavior like this, with 3 not having a value, that would be something like, that would be something like 1 over x x minus 3. So if we plugged 3 into this function, we would get 1 over 0, which is division by 0, which we know is dne. So in a function like this, if they gave us a value that was greater than 3, we would get a positive outcome. So we would see in this function maybe something like this. Now these aren't exact values, but we would see something like this. This value might be something like 10,000. Meanwhile, 3.001 might be something like 1,000. And 3.01 might be something like 100. Now looking at this graph, we can kind of see already that as our x approaches 3 from the right-hand side, it appears to be getting towards some really, really, really big number. So we can conjecture that it's probably going towards infinity, as it would be in 1 over x minus 3. Now, from the other side, 2.9, 2.99, 2.999, those are all values that are a little bit less than 3. And so if we plugged into there, we would get something perhaps. Now, these aren't actually values plugged into this function, but you get the idea. This would be negative 100. This could be negative 1000, just like the other side. And you will see some degree of symmetry here. And this could be negative 10,000. So, as a result, we can kind of see now on this side that as x approaches 3 from the left, we appear to be getting closer and closer to negative infinity. The value is getting very, very small. And so, graphically, if we were looking at this asymptote would be something like this, where it's getting really big on one side, but underneath, we'll clear up a little garbage here, but underneath, it's getting very, very small. And that's what this function would look like, x minus 3. 1 over x minus 3. And so with that table, we can kind of come to the assumption of what's going on at x equals 3, even though we don't have a value at x equals 3. It's null. We can still see that there is the right-handed behavior of limit of, we'll call this f of x, as x approaches 3 from the right. Here, it appears to look like infinity. And we can make a pretty good conjecture, and we can choose values that are even smaller as well. The table could have 3.0000001, and that would be an even larger number, with more zeros, like 1 billion. And so we can also see, looking at this table, that it's going to be the limit of f of x as x approaches 3 from the left. That's going to be negative infinity, because the values are getting smaller and smaller, from negative 100 to negative 1000 to negative 10,000. These are all much smaller values, an order of 10 smaller than the last. So as a result, we're approaching negative infinity, and we can conjecture that as we get further and further, or as we get closer and closer to 3, we're going to have further exaggerated x or y values, more positive and more negative. So that's what we have. And going off what we've mentioned in the previous video and the video before that, since the right limit is not equal to the left limit, so as x approaches 3 from the left, and rather from the right, does not equal as x approaches 3 from the left. Since they're not equal to one another, infinity is not equal to negative infinity, then our general limit, f of x, as x approaches 3, this does not exist. That's very important. Remember, if left-hand limit is not equal to right-hand limit, left-hand side not equal to right-hand side, then the limit does not exist. This is super important, and we'll get into that in a little while with continuity as to why that is particularly important. But remember, if left is not equal to right, it does not exist. Now the same thing goes for tables that have a little bit more boring behavior, like a table like this, for example, where they give us our x values and they give us our y values. Oh, forgive me. They give us our x values and they give us our y values. Say x equals 3, they give it to us is 1. Well, that's pretty basic. And they give us the other values around it as well, as say, well, let's look at the other x values. Say like 2 and 1 and 0 and negative 1 and 4 and 5 and 6 and 7. So if they give us a function or table like this and they give us values that look like this, like at here and here and here and here, it's just going to go up incrementally by 1 and go down incrementally by 1. That is not incrementally by 1. Okay, go down incrementally by 1. Now we see that this appears to just be a plain old line that has a slope of 1 that crosses through the point 3, 1. So this is not very exciting. In fact, we see that it has a point 20, so we can pretty well conjecture that this is going to be y equals x plus our y-intercept at x equals 0 is going to be negative 2. So y equals x minus 2. And so now if we plug in any x value like 2, we get 0. If we plug in 3, we get 1. So this is a very basic line, and the line has really nice behavior, because if we were to graph this out with its y-intercept at negative 2, here, this is negative 2. If we were to draw this out, it would just be a nice straight line like that. And at any given point, there aren't any discontinuities. It's going to have beautiful performance. There aren't any asymptotes. There isn't any division by 0, no square roots of negatives, anything like that. And so at any point, we can plug into the function without having to worry about anything like 1 over 0, this being your answer. So as a result, this has a limit everywhere, and it's very easy to calculate the limit at any given point. So if they tell us, what's the limit at x equals 2, at x approaches 2 of this function, well, it's just going to be f of 2, as we've determined, and that's going to be really straightforward. It's just going to be 0, because we have that entry at x equals 2, y equals 0. We're just plugging in. And so this is a nice behavior of table. And mind you, we're probably not going to have to deal with horizontal asymptotes very much on tables, because tables are not equipped to represent end behavior. So, as a result, you're not going to see things like y, or like x equals 1,000, x equals 1,000,000, and it's going to show you y values that are getting closer and closer to 6 or something like that. But even if it does, it's very intuitive. You'd see the y values getting closer and closer to some value, and you would know that we have a horizontal asymptote. But typically this is only going to be used with things like vertical asymptotes and discontinuities as a result of asymptotes or jumps. There could also be the case where it shows you a function that has a value, and we'll show this is sort of a bit of a distant case. You probably won't see this one too much, but if they give us a function with the table that looks like this, where they tell us at x equals 3, the y value equals 0, or any, and we have this same kind of look to it, where on the right-hand side, it might be doing something really, really nice. On the right-hand side, we could have, we're just going to have 4, 5, 6, and 7 as our x values. Mind you, this is x and this is y. And we could have 2, 1, 0, -1 as our x values. Well, we could see here something really nice on the right-hand side. Something like 1, and 2, 3, and 4, where it's just linear. But on the left-hand side, it could be doing something completely and utterly different and scary. And that could be something like 0, 0... Well, let's actually look at something like this. Let's look at -0.09. Or even closer, let's look at -0.99. Right, that's really close to -1. -0.999. And over here it could be -0.99. And over here it could be -0.9. And so we end up with this. And on this last point over here, maybe it's just -0.5. So we kind of can see here that there's an asymptote going on the right-hand side, on the left-hand side, but not on the right-hand side. So we might have a function that looks a little bit kind of linear, where at x equals 3, we have this nice y equals 0. And it does something like this. But on the other side, it's got this asymptote that's going up to -1, or rather y equals -1. And so that is a little bit weirder, where we have something like this going on, where it gets up to that point, but then it doesn't jump over it, and it suddenly leaps into 3. And so this is going to have weird behavior again, where we can see the left-hand side does not equal the right-hand side, and so the limit does not exist. And the limit from the right-hand side is going to be y equals 0. The limit from the right-hand side is y equals 0, and the limit from the left-hand side is y equals -1. But this case is probably going to occur a little bit less, but you must be prepared and always ready to draw out these functions if it does come to be necessary. And by drawing it out, you'll be able to see better the behavior and better to trace it with your fingers to see what this function is doing at what points. But that's all we have for dealing with tables and finding limits of tables. And we'll move on to the next topic in the next video. Thank you.